Hi, this is Mr. Beck Does Your Homework. This is AP Physics, homework number 25 on rotational kinematics. This question is question number 7. It says the wheel on an upside down bicycle moves through 17.2 radians in 5.79 seconds. So that means that it has a displacement of 17.2 radians, and the elapsed time for that is going to be 5.79 seconds. So that's giving me my displacement in some amount of time. I'm looking for the wheel's angular acceleration, so I'm looking for my alpha if its initial angular speed is 2.6 radians per second. So I know that my initial angular speed is going to be 2.6 radians per second. Now, I know it would be tempting to look at the 17.2 radians in 5.79 seconds and say, oh, that's going to be my angular velocity. Maybe that's my final angular velocity, but that's not the case. So this is my displacement. That's my time. There's my alpha, and there's my initial angular velocity. Now, if you remember your kinematics equations, we had our 4 kinematics equations, and one of them was that my displacement was going to be my initial velocity times time plus 1/2 my acceleration times time squared. And this equation did not have the final velocity. Well, this is the same sort of thing. We're going to have the equation of motion for angular acceleration, and it's going to say that my change in position in an angular term, my change in angular position, is going to be my initial angular velocity times time plus 1/2 of my angular acceleration times time squared. So we're going to use this equation in order to solve the problem instead of dealing with that, trying to solve for a final angular velocity. I actually don't need that because I have these values. So now I'm going to plug in for my displacement of 17.2 radians for my displacement. I know that my initial angular velocity is 2.6 radians per second, and the elapsed time in this problem is 5.79 seconds, and that is here and here. And then I have the 1/2 of my angular acceleration that I'm looking for times the time squared, 5.79 squared. So now it's just an algebra problem where I have to do the work and solve for that angular acceleration. But this is an example of the kinematics equations that we know, but doing them in angular terms, but just replacing each variable with the linear version versus the angular version. So in this case, I'm given my values and I have to solve for my angular acceleration. And so that is how we solve this problem, problem number 7.